So let's remember again where we're going and how we're getting there. Our ultimate goal is we want to convert points. So we take a point, we don't move the point, right? But we want to say, I know the location of this point relative to one coordinate frame. What is its location relative to another coordinate frame? And we started by talking about just one very simple category of problems, which is transformations where you just have to do a translation. It may just be a translation along one axis, or it may be a translation along a bunch of axes. It might be along all three, x, y, and z. But how did you do a frame transformation, right? This was my capital F thing, where you're moving one frame to align with another. So for example, I might ask you, what is F from C to M? And I'm asking you, how do I align this C frame? How do I move it relative to C's X, Y, and Z so that I can end up aligned with M's X, Y, and Z? And in the case of this example, we had to move, let's see, here's the x-axis, right? So we had to move out by 5 units. There, it's labeled there, in the positive x direction. And then we had to, y goes positively this way, but we need to move this way. So it's -4 units. And we need to go down, and z goes up, so that's -1. So we end up with 5, -4, -1 is the frame transformation from C to M. So we started with things like that. And then we took those frame transformations and we talked about how that relates to actual point transformation. So transforming the coordinate frame that you're looking at the point in, right? Again, we're not moving the point stays still. We're just talking about how does the point, where is the point in this frame and where is the point in another frame. And of course, at some point, what we really want is to be able to do an arbitrary number of rotations and translations and more rotations and translations and understand how does the frame transform for that work and how does the the homogeneous transform, which will transform points work. We're going to continue to move there very slowly. In this lecture, we're just going to talk about what happens if you have a single rotation. So you're rotating about just one axis. So let's talk about this problem. Let's suppose that this is my C coordinate frame. And here's my D coordinate frame. Now their origins are actually co-located in the same spot, right? So let me color it in red because everything else is colored in already, right? So this is the origin of the C coordinate frame. It's also the origin of the D coordinate frame. So they're on top of each other, but it's important to notice that, well, their x-axes are the same, but C's y-axis is going up and down. D's y-axis is pointing out of the page. C's z-axis is also pointing out of the page. So C and D, in addition to having the same x-axis, C's z-axis is the same as D's y-axis. And then D's z-axis is just pointing straight down. So I may split them up just so that it's easier to see each one of these axes separately, each of the coordinate frames separately. But what I want you to remember is at all times, really, their origin is right here. They're both on top of each other. So I want to figure out what is F from C to D. How can I align the C axis with the D axis? Before you do that, you may just want to say, all right, I'm going to do this in my head now. If I take the x-axis and go into the y, it goes to z, right? If I use my hand, you can't see me doing this, right? But I'm curling my fingers from x to y and making sure my thumb points at z for this one. And now I am curling my fingers from x to y and making sure that my thumb points at z. Just to make sure that they're both right-handed coordinate frames. Basically, I am checking to make sure that your professor hasn't messed up on this. And I haven't, hooray. So what I want to know is what is the frame transformation from C to D? How do I align C coordinate frame so that it aligns with D coordinates? And I think I'm going to look at this one to figure it out. And I already gave you a heads up that it's just going to involve one rotation. And if you look at this for a minute, you can see that since x and y's since C and D's x-axis is the same for both of them, I could kind of leave that alone. Again, I'm trying to move C into position with D. So what I really want to do is I want to kind of hold on to the x-axis and sort of spin it, right? Imagine this is if we look over here for a second, if I take this and I rotate it so that there we go, so that this guy is going to spin around like that. And so if I rotate it by 90 degrees, by the time I'm done, this y-axis will be down where the z-axis is, and the z-axis now will sort of have rotated down to be pointing down. If you can't, my drawing here is not the most beautiful ever, but clearly I need to rotate this guy. So this guy is going to stay in place. The x sub c axis is going to stay in place, and I'm going to rotate the whole axis by 90 degrees. What I want you to do is to get a few, if you have Tinker Toys, great. Tinker Toys are wonderful. If you don't have Tinker Toys, then use 3 pencils stuck together or something, just to show yourself what's going on with this rotation. Now, of course, just to review, I said we were doing a rotation like that, right? And I need to figure out whether that's a positive or a negative rotation. It's 90 degrees for sure, but is it positive or negative? And remember, the way I do that is I take my right thumb and I stick it along the direction of positive xc, and I say which way do my fingers curl when I do that. And looking at it, it turns out this is a positive direction of rotation. And so what I'm going to say is, to do the frame transformation from C to D, I need to rotate the x-axis, so keep the x-axis not moving except for rotation, and rotate it by positive 90 degrees. Just for fun, let's think about it the other way. What happens if I rotate these axes the other way? So I want to figure out what is the frame transformation from D to C. I want to take my D axes and figure out how do I get my D axes so that they align with my C axes. And this time I need to be doing my rotation this way, right? So I'm going to be rotating that axis I'm using my thumb now and my fingers to take a look. That's a negative direction. So if I rotate about the, if I rotate about the x-axis of D by negative 90 degrees, then I'll end up with D's y pointing up and D's z pointing out. And so the notation I'm going to use is I'm going to say the frame transformation from D to C, that's the old notation we've been using before, is do a rotation about the x-axis of negative 90 degrees. Let's just do one more example. So here's another example. Now I have 2 coordinate frames E and H. And if we look at them again, they share a single origin, right? But their axes don't exactly line up. So if we look, it looks like the H's x-axis is in the same direction as Y's e-axis, right? So that's this axis. They share a z-axis, and the e-axis has x pointing up, the h-axis has y pointing down. So these are our 2 coordinate frames. And now I'm trying to figure out what is the frame transformation from H to E. How do I transform frame H so that it's aligned with frame E? And when you look at this, of course, the z-axes are already aligned, right? And if we think about it, what do we need to do? We need to take this h-axis, right? We need to take this x, and to make it align up with E, this x needs to sort of move up by 90 degrees. And similarly, to make H's y-axis turn into E's y-axis, this axis needs to rotate up by 90 degrees. And how do we get those to align in that way? Well, the way we do that is we say, all right, I guess I need to rotate, I need to rotate the z-axis that way, right? Because if I hold on to the z-axis and sort of twirl it, then, because remember z is pointing into the paper, then my h-axis, the y part, will come up here, and my h-axis, the x part, will go along there. So, so again, we need to figure out, is this a positive or a negative rotation? Hang on, let me just get rid of all this mess. So I need to figure out which way is positive rotation for h's z-axis. So I'm going to stick my thumb that way. And so then when I curl my fingers and I need to try and draw how they move, this is a hideous picture, but there you go. That's my fingers curling around this way. I don't know if this is helping at all. But so my thumb is pointing out. So the positive direction of rotation, let's get rid of that. Positive direction of rotation for the z-axis is this, is this way. But we're actually going this way. So that means that we need to do a rotation about h's z-axis of negative 90 degrees. And so we're going to write that the frame transformation from H to E, how do we move the H frame so it's in alignment with the E frame, is rotate about the z-axis by negative 90 degrees. And let's just try it the other way. If we want to figure out how do we go from E to H, how do I align the E axis, or so the E frame, right? The E coordinate frame, so that it's in alignment with the H coordinate frame. And if we look, it's not surprising. We just need to sort of unwind, right? We're going to go the other way. And so if I do a rotation like that of 90 degrees, then E's x-axis will end up here. Let's change colors. E's x-axis will sort of go down there, so it'll be pointing horizontally to the right. E's y-axis will be going down that way, so it'll be pointing straight down, which is exactly what we want. Since ZE and ZH both go in the same direction, we know that if I put my thumb this way and curl my fingers, I'm not going to try and show you my fingers curling, but they're also going to go that way. So we need to do a rotation of positive 90. And there's a pretty slide that tells you the answer. Woohoo!